Hello, welcome back. I am Rajendra Bade. In this video, we'll continue with topic sectional orthographic views. Refer the figure and draw sectional front view along section AE, top view, and view from left. Insert the major dimensions. Okay, as usual, we'll continue. Focus on the arrow suggesting front side of the object. Parallel to this arrow, that is width axis. So this is width axis. Of course, vertical height axis is height and the third axis is length axis. Now we'll check overall dimensions of the object. Length. Focus on dimensions parallel to length axis. So 30 millimeter. Extreme left edge is curved edge. Its radius is 30 millimeters. Check here. Diameter of this circular edge is 60 millimeters given. 30 millimeters is radius. So up to center of the cylinder, parallel to length dimension is 30 millimeters. Then 40 millimeters, that's given here, check. 40 millimeter that parallel to length dimensions. And then the extreme top portion is truncated cone like portion, frustum of a cone you can say. Its base is circular of radius 30 millimeters. Check here, 60 millimeter, that is this dimension is given parallel to width, that is nothing but diameter of the base circle. So radius of the base circle, check here. Generally hidden details are not shown in three-dimensional diagram, but for your reference I have drawn a dotted line here suggesting you base of this truncated cone. So its radius is 30 millimeters. So 30 plus 40 plus 30, overall length from extreme left to extreme right, it is 100 millimeters. So this is length 100 millimeters. Now focus on height of the object. Check all vertical dimensions now. Lowest edge is curved edge. Its radius is 30. Diameter is 60. So diameter is 60 from base. From top of this cylinder, 36 millimeters we'll have to add. 36, check here, vertical dimension given. So 60 plus 36. And above this plate, you should consider height of this truncated cone. And how much is that? 40 millimeters. So 60 plus 36 plus 40. So total height is 136 millimeters. Now focus on width of the object. Width is directly available here, 80 millimeters, from extreme front to back. Widest portion of the object is here. That is nothing but axis length of the cylinder. It is 80 millimeters. It's given. So width of the object is 80 millimeters. Okay, watch here. When you can identify different portions of the object, then consider it as a very simple problem. Check here, there is a cylinder at base, a hollow cylinder. There is a cone at top, not complete cone, it is a truncated cone or frustum of a cone. It is also hollow, that is it has coaxial hole of diameter 20 millimeters. Then there is a U-shaped horizontal plate. Then there is a vertical plate. And then there is a rib here, a plate of thickness 12 millimeters. So easily we could identify all these parts: cylinder, truncated cone, horizontal plate, vertical plate, and a rib. So step by step we'll draw views of this object. So let's proceed. What you are going to do first? 3 rectangular boxes. 3 rectangles you are going to draw. 2-dimensional rectangles for front view, top view, and side view. Which side view you are asked to draw? Left hand side view. So there must be enough space on the right side. Okay, so let's focus on first length and height view. That is front view. So length horizontally and height vertically. So how much is length? 100 millimeter. Height 136. So complete that rectangle. Length 100 millimeter. Height 136 millimeter, and complete a rectangle. These are not edges of the object. So don't make this rectangle dark. Now we have already measured length. Which 2 dimensions you get in the top view? Length horizontal and width vertical. How much is width? 80 millimeter. Now we have already measured length of the object as 100 millimeter. So for top view, you need not measure that 100 millimeter length. Instead, you project that length in the top view. But before you draw top view rectangle here, be sure that there is enough space between front view rectangle and top view rectangle, we leave about 20 millimeter space between the two. And this is width vertically. So this is how we have completed length horizontal 100 millimeter and width 80 vertically. And now for side view, length doesn't appear in the side view. So which two dimensions you get in the side view? Height vertical and width horizontal. Now width horizontal, we have already measured width in the top view, but in the top view width is vertical. You should project it in the side view, and to project it in the side view you should draw a line at an angle 45 degrees from right side corner. When you want to draw left side view from right side bottom corner of front view, draw a line at an angle 45 degrees. Now we'll draw necessary projectors. We have already measured height 136 in the front view, width 80 millimeters in the top view. Now you must not measure these dimensions again for the side view. Instead, draw end projectors. Transfer height from front view to side view and transfer width from top view to side view. So this is how we have transferred height, same height 136 millimeters of course in the side view, and width 80 millimeters by rotating these projectors by 90 degrees. So this is how width 80 millimeters and height 136 millimeters. Now this is new instruction. No, not at all. I'm giving you an instruction. I've given you this instruction many times earlier. Now watch here. Object is symmetrical. Front side and back side are symmetrical. So it's always better to draw axis of symmetry immediately if object is symmetrical. Immediately after you construct these three rectangles. Front and back symmetry it is. So you cannot draw axis of symmetry in the front view because in front view front and back overlap. Four sides you get in the front view. This is right side, this is left side, this is base, and this is top. But in the top view, this is front side and this is back side. So all details on the front side and all details on the back side here are identical, and that's why there should be axis of symmetry here. So 80 millimeter width, measure 40 millimeters and draw axis of symmetry and project that axis of symmetry in the side view also, because this is front side of the object and this is back side of the object. So there must be vertical axis of symmetry in the side view. So this is how we have drawn axis of symmetry, and now we should proceed part by part. Let's draw the cylinder first. Smaller details, that is this hole or this hole here in the cone, little later. We'll focus on the cylinder which is at bottom. It is circle in the front view. From front its circular end will appear, and in remaining two views that means it's rectangle. So let's proceed in the front view. It is on the base and left side. So consider base left side corner. What is the radius of this circle? Diameter is given 60 millimeters, so radius 30 millimeters. So from this corner, measure 30 millimeters and draw center line. So watch here, this is that center line which is parallel to height. We have drawn here parallel to height. For this circular end of cylinder, there is one more center line. Here it is, and it is parallel to length. So parallel to length center lines, a line we will have to look at. So now measure 30 millimeters, that is radius, and draw parallel to length center line. And this is how center of the circle. Here is the center of the circle. Check that red dot in three-dimensional view. Here is center of the circle. We have identified in orthographic view. Now with radius 30 millimeter and this center, complete circle. So this is cylinder in the front view. Now remaining two views, it appears simply rectangle. Width of the rectangle should be 80, and in the top view width is 80 to be measured vertically. So draw end projectors and complete the rectangle. And again in the side view, draw end projectors and complete the rectangle. So 80 millimeters and this height is diameter. So it is cylinder. We have not made this circle dark. You are asked sectional front view. So right now don't make it dark, but cylinder in the top view and cylinder in the side view. When a cylinder appears a rectangle in a view, you should draw axis. So draw axis of the cylinder in the top view and in the side view. So cylinder is oval. Now let's proceed for this truncated cone or frustum of a cone. So base has diameter 60 millimeter, top has diameter 40 millimeters, and hole has diameter 20 millimeters. We'll draw hole later. Let's focus on that solid portion, the frustum of the cone. In the top view, it appears circle. So top circle of diameter 40 millimeters. Top circle of diameter 40 millimeters. But check here. Center is from extreme right. Center of base is of radius 30 millimeter. Base is 60 millimeter diameter circle. So radius 30 millimeters. So we should measure that radius 30 millimeters from right end. To locate center of the base circle and top circle. So this is a base circle. And watch here, this is top circle. So base circle and this top circle, top surface boundary we have drawn here. And now we'll draw this cone in the front view. It is topmost portion of the object. So draw in projector. Here it is top surface and base surface. And this is how that cone or frustum of the cone is ready. Now draw in projectors. That is transfer height of this portion. Draw in projectors from front view to side view and end projectors from top view to side view to complete that cone in the side view. Watch. These are the projectors, that is we have transferred height of this cone, that is 40 millimeters. You can measure 40 millimeter independently instead of drawing these projectors. Okay, so we have transferred that height 40 millimeters and we have completed it. Top is 40, base is 60. Correct? Top 40 and base 60. You may draw projectors here from top view to side view. So this is how this cone is ready in all the three views. In the top view, base circle and top circle. Top circle is smaller because it is portion of a cone. So this is top circle which appears line, base circle which appears line. Now again try to understand, in the top view we have not made it dark because we are going to draw sectional. In front view we have not made it dark because we want to draw sectional front view. In the side view, this portion we have made it dark. In the top view also, this conical portion we have made it dark. Okay. Now, very important thing which I have explained you earlier also. Check here, listen to me now very carefully. This is a front view of cylinder and this is front view of the truncated cone. This is side view of the cylinder and this is side view of the truncated cone. And here top view of the cylinder and here it is top view of the truncated cone. Now top views of these two portions, cylinder and truncated cone, top views of these two portions overlap, and that is why we should check in the top view, that is when observer is watching from top, which portion is closer to observer. So this truncated cone is closer to observer. That means the overlap portion of the cylinder is hidden. So this overlap portion of the cylinder we should draw hidden. Have you understood this hidden line? So no intelligence is required. When two portions of object overlap, then check which portion is nearer to the observer and the other portion is hidden, not entirely. The portion which is overlapping with the part which is nearer to the observer. So this portion is overlapping with the part, that is this truncated cone, which is nearer to the observer. So this portion we have drawn dotted. Okay. So now let's proceed for this horizontal U-shaped plate. Check here this U-shaped plate. This curved edge of this plate is coinciding with the base of the cylinder. Now focus here where right now red dot on your screen is. Check here, I have drawn that base circle. Okay. So this is that U-shaped plate. So its U-shape appears in the top view, and in front view and side view it should appear a rectangular strip. After all, it is simple U-shaped plate. So let's complete that U shape. Principal edge. Curved edge is already available here. Because curved edge of that U shape surface, this curved edge is coinciding with the curved edge of the base of truncated cone, which we have already drawn here. Now we should draw these three principal edges parallel to width and these two edges parallel to length. So watch here, I am drawing. Top view is symmetrical view. So we should measure width. What is that? 60 millimeters. Check here. Parallel to width dimension 60 millimeters. In the top view, width is vertical. So measure that width vertical. This is 60 millimeters. Now other two principal edges to complete that U shape. Watch here. This is that U shape. U-shaped pleat. Okay. Now watch here. This is top view of a cylinder at base or at bottom. And here it is a top view of U-shaped plate. There is overlap. But check here, cylinder is under that U-shaped plate. So U-shaped plate, the overlap portion is not hidden. Try to understand. Okay. So this U-shaped plate will draw here as a rectangular strip of thickness 20 millimeter. Now thickness of this plate is 20 millimeter, but it is vertical, that is height. So measure that thickness 20 millimeters. And U-shaped plate, check here the entire U-shape in the top view. You should draw projectors and complete that rectangle. So this is that U-shaped plate in the front view. Now transfer this height of the plate 20 millimeter in the side view. And from the top view, width is 60 millimeters, you transfer in the side view. So these are called end projectors to transfer the width. And this is how you will get that rectangular plate or rectangular strip indicating that U-shaped plate in the side view. Okay. Now we'll draw this vertical plate. Okay, this vertical plate which is under the U-shaped plate. So check here. Focus on the screen where this red dot is right now. So watch here, this vertical edge, it is here. This vertical edge up to the cylindrical surface. Now we'll draw this vertical edge. Watch here. It meets cylindrical surface, not tangentially. Check here, there is sharp corner here. Okay. So now focus on the red dot and try to understand. This is front view of that vertical plate. This plate is vertical. So this is a front view of the vertical plate. So to draw its side view, we should draw end projectors in the side view. That is transfer height of the plate. And to draw it in the top view, draw end projectors. Let's complete the top view first. So draw end projectors from that plate and complete that rectangle. Now watch here. Where is this plate in the top view? If I ask you, you should show me this entire rectangle. And this rectangle is dotted under the U-shaped plate, hidden under the U-shaped plate. So this entire rectangle is dotted. But out of these four edges of the rectangle, these three edges are overlapping with the earlier drawn visible edges. But the entire rectangle which is dotted is present here. Okay. Now let's draw this plate in the side view. Watch here, this is that plate. Focus on the plate and draw in projectors from top of that plate and from lowest point on that plate. That is height. From lowest point to the highest point, that is height of this plate. So this is how we have transferred here from front view to side view. And now width of this plate is 60 millimeters. 60 millimeters. So project it in the side view. Okay, this is 60 millimeter, which we have already projected earlier for this upper U-shaped plate. So this is the rectangle. Have you noticed? The portion which is overlapping with cylinder, that portion I have drawn dotted because this portion against this corner, this is that edge where that plate meets curved surface. This edge from left side is hidden because this is front side of the cylinder and this is back side of the cylinder. This edge is on the back side. When object is watching from left side, towards the observer, this portion visible and this is hidden portion. That is why this portion is hidden. You will have to think in this manner only. Is there overlap? Yes. So which portion? Cylinder or this plate which is nearer to the observer? The cylinder is nearer to the observer. So overlap portion of the plate is hidden. Okay. So this plate is also over in all the three views. Now let's proceed for the final plate, that is the rib. Its largest surface, watch here, appears in the front view, and the remaining two views it should appear a strip. So its largest surface, easily we can create it because this plate is in contact with curved surface of the cylinder and that vertical plate, this vertical plate. Okay, so let's draw it here. Before that, watch here, this is hidden line. Remember these two edges where they meet, these two plates where they meet here, there is no sharp edge. So I have erased the dark line here and I have drawn a dotted line. Dotted line is for this corner or for this corner. A corner is formed by three edges. Watch here, this corner. Against this corner there is an edge. Remember, a corner is formed by three edges. This edge is a parallel to height. This edge is parallel to length. And from this corner there is third edge which is parallel to width axis. In the side view, width is horizontal. So even if you have erased that dark continuous line, there should be a dotted line here, that is hidden edge from this corner. From this corner, this is that hidden edge. Okay, and now we'll draw that rib. Watch here, this is that rib. In the top view, transfer end projectors. Watch here. So this rib is tangent to the curved surface here. Watch, it meets tangentially. So that is why just from this corner, this corner in the front view represents this entire edge. So from that edge, you should draw the boundary, this edge of the rib. And you should manage it tangent to the circle. Okay. So where it is tangent to the circle, from that point, the projector is. So this rib, watch here, this is the largest surface of the rib. From extreme right side end of that rib and extreme left corner of the rib, you should draw projector. And that left corner of this rib is nothing but where it is tangent to the cylindrical surface. So this is how we have drawn those two projectors. Now here symmetrically you measure thickness, 6 plus 6, that is 12. Thickness, watch here, 12 millimeter. It is parallel to width axis, and width axis, that is vertical in the top view. So in the top view, width is vertical. So measure vertically 12, symmetrically, that is 6 millimeter above the center line, 6 millimeter below the center line. So this dark line here, it is 12 millimeters long, and complete the rib. So between end projector, exactly between the end projectors, that rectangular strip here. But there is a mistake. Watch here, the earlier drawn this 12 millimeter long thick line here, that should not be there because here there is no sharp edge. It meets cylindrical surface tangentially. So that line, vertical line, must not be there. Check here how we showed tangential joint. So I have removed it and show these small curves at the end of these two edges to indicate tangential joint. Okay, so top view of that rib is complete. Now let's draw this rib in the side view also. So height of the plate, so highest point of that rib, that is this corner, and lowest point on the rib, that is nothing but where it is tangent to the cylinder. From these 2 points you should draw projectors. From lowest point on the rib to highest point on the rib, that is the height of the rib. Height is vertical, so that height you should transfer in the side view. And the rib 12 millimeter thickness you can transfer from top view to side view. So this vertical 12 millimeter dimension will become horizontal in the side view. So you may measure it independently. So this is how we have completed the rectangular strip in the side view. But remember here, watch here, this red colored horizontal line. This is projector. From the point where that plate is, or surface of the plate, this strip like surface of the plate, where it meets tangentially to the cylindrical surface, from that point this projector is. So here we should indicate that tangential joint using these small curves. Okay. Then on boundary of a cylinder, boundary generator of a cylinder, when there is an attachment, this boundary inside the attachment to be erased. So I have erased it. So trim that portion. Okay. So this plate is also over in the side view. So top view, side view and front view. Front view we have not yet made dark because we are going to draw sectional front view. Except these two holes. This hole opening appears in the front view here, and in the top view dotted rectangle, in the side view dotted rectangle. And this vertical hole, so its a circle appears in the top view and dotted line in the front view, dotted line in the side view. But right now we are not going to draw complete front view. So let's focus on those instructions I've given you earlier, or important points about sectional view. Two portions of an object, listen to me very carefully. Two portions of an object, when they get cut by a cutting plane, boundary between the two portions, you will have to erase it. Correct? So here this conical portion and that U-shaped plate, boundary between this conical surface and surface of the U-shaped plate, this boundary you will have to remove. It will not come in sectional view. Okay. So this is how I have removed it. Now remember, this is horizontal U-shaped plate and this is vertical plate. This boundary also you will have to erase. Now vertical plate meets cylinder. So boundary between vertical plate that is this plate, that is this surface of the plate, and the surface, ring-like surface of cylinder. Boundary between these two surfaces, that is this edge, that is to be erased. So this is very important instruction I have given you. When two portions of an object get cut by a single cutting plane, then boundary between the two portions to be erased. So that is why we should erase this boundary and we should erase this boundary. Actually, this rib here is also getting cut. Check here that cutting plane AA. This is how it makes exact two halves of this object. So this rib also is getting cut. When you imagine a cutting plane line here, watch here. It cuts the rib, its thickness into two halves. But the instruction in sectional view I have given you. What it is? Listen once again. If largest surface of a plate appears in sectional view, so this rib has its largest surface in the front view and we are drawing sectional front view. If largest surface of a plate appears in sectional view, then the plate is to be imagined uncut. So here right now we'll assume that this rib is not getting cut because of the cutting plane. And that is why we must not touch its boundary. So don't erase this boundary, don't erase this boundary. So which two points I have revised here up till now in sectional views? Listen, two portions get cut by a cutting plane, boundary between the two to be erased. So we have erased this boundary, we have erased this boundary. Okay, now let's make the boundary. You never get hidden lines at boundary, so make boundary dark. Check. Now let's draw those two holes. Okay, this hole in the cylinder first. 15 millimeter its radius. Circular opening appears in the front view. So corresponding dotted lines in the top view. This hole is in the cylinder. So watch here these two dotted lines. This dotted line and here it is dotted line. So this complete rectangle is that hole in the top view. Okay, let's draw this rectangle in the side view. Draw end projectors. Watch here. And these two dotted lines indicate this hole in the side view. In front view, this is that hole. Okay, now there is one more hole here, this hole. Its opening appears in the top view. So focus in the top view. So this is that 10 millimeter radius hole. Now project it. It is in that conical portion. But when depth of a hole is not given, we should assume a through hole. So draw dotted line showing opening at the lower side also. So watch here. Hole is from top and here it is open. So top to bottom, that hole, bottom of that U-shaped plate. So this is that hole. But I have not drawn dotted line here. Simple. This hole is getting cut by the cutting line. Here is the cutting line. Check here this cutting line. This hole is getting cut by the cutting line. So in sectional front view, this hole is visible. So don't draw hidden lines here. Okay. Now we'll draw this hole in the side view also. So check those dotted lines. End projectors, you should imagine. And this is how I've drawn that hole. So this hole is in the side view also. So front view, top view, side view are complete. Only thing is now in newly generated surface, we should draw hatching lines. Now first very important thing, newly generated surface due to cutting. This is the hole that is getting exposed. This rectangle is original inner surface of the hole. So whole portion is not to be hatched. This is whole. There is no material here. So don't show hatching lines. When cutting plane cuts solid portion of object, then new surface gets created. Okay, so this circle that is hole, you should not hatch inside the circle. You should not hatch inside this rectangle because that is also the hole that is getting exposed. And this portion, watch here, this plate, rib here, don't show hatching lines on the rib. And remaining all portion, we should show hatching lines. Before that, we'll show cutting line here as usual. It's center line only. End dash is dark. And the direction in which observer is watching that sectional front view, in that direction, show the arrows. If it is labeled in the given diagram, you may label here. So AA. This is cutting plane line AA. And now finally, draw hatching lines. So this is how I've drawn hatching lines in the portion. So sectional front view is also complete. Now insert all dimensions. This is complete drawing. We use first angle method of projection. Watch here. This is the truncated cone which appears here in this object. It's the same cone here. Base is wider. One end is wider than the other end, but both ends are circular which appear here. Similarly here it is the same truncated cone. Okay. Thank you for watching the video.